Good morning to all of you. I am Dr. Neetu Gahlot. I am working as assistant professor in St. Andrews Institute of Technology and Management, Gurgaon. Today, I am taking my 20th lecture of chemistry, and this is our first unit. And the topic which is covered in this lecture, these are the pi molecular orbital in butadiene and the benzene. So let's start our topic, in which we are discussing about the pi molecular orbital in 1,3-butadiene, or it is called the butadiene also, and the next is the benzene. So first of all, we should know the structure of the butadiene. As here we can say, we know that there are the 4 carbons. Okay, so here we can see the structure. This is the structure of the 1,3-butadiene. There are the 4 carbons are present, and the double bond are present at the first and the third carbon. Here we can see that here's the bond length between the carbon-carbon single bond. It is a 1.48 angstrom, and in the double bond there are the 1.34 angstroms bond length. So now, uh, pi molecular orbital कब बनते हैं? Molecular orbital कब बनते हैं? So we know that when the atomic orbitals overlap, so the molecular orbitals are formed. Clear? If one atomic orbital अगर है, हमने molecular orbital theory में पढ़ा था कि one atomic orbital is there, so it means the one molecular orbital present. It means it means कि if two atomic orbitals are joined together, then there is the formation of the molecular orbital. Okay, so here the single bond is shorter than the 1.54 angstrom. The electrons are delocalized over molecule, and there are a small amount of the overlap across the central carbon-carbon bond, giving it a partial double bond character. One thing is important that we know about the molecular orbital, and we know that when the atomic orbital overlap, then there is the formation of the molecular orbital. But सब नहीं होते, but only those orbital which is perpendicular of the molecular axis. Okay, so here pi molecular orbital, here we can see that the pi molecular orbital are the, कैसे होते हैं कि वो सामने सामने से overlapping होगी, of the sideways overlap of p orbitals. Okay, so the p orbitals have two lobes, one is a plus and one is the minus. Okay, and they indicate the plus or minus indicate the opposite phase of the wave function, not the electrical charge. We know about the wave function. What is wave? वेव कैसे मूव करती है, एक बार ऊपर एक बार नीचे. तो इट मीन्स जब ऊपर की साइड वेव और नीचे की साइड when they meet at a point, that point is called the node. Okay, and the possibility of the finding the electrons at the node, that is 0. It means कि node के पास में कोई भी इलेक्ट्रॉन नहीं होते हैं. So the when lobes overlap constructively, when the or we can say they add, overlapping is in the same phase, or we can say that is a plus or plus, or minus and the minus. So there is a formation of the molecular bonding molecular orbital. Okay? And when the positive and the negative lobes overlap, the waves cancel out and the node form. Here is a formation of the node, and there is called the antibonding molecular orbital. So now we know that there are the two types of the molecular orbital. One is the bonding molecular orbital, and another is the antibonding molecular orbital. And if the node is present, so it means there is the no electron. And bonding molecular orbital is formed when the phases are the same, and the antibonding molecular orbitals formed when the opposite phases are here. That is, or we can say that is the subtraction of overlapping. Okay, so this is the general introduction of the molecular orbital. Now we come to the example, that is the 1,3-butadiene. So here we can say there are the 4 carbon, so that 4 atomic orbital, so that there are the 4 molecular orbital also, so that represent C1, C2, C3, C4. Okay, and this is a p orbital for each carbon. So now we can say at the we can say this is the pi one of the shy one, that is the first stage. So here's the lowest energy, because we can see that all the loops are present in the same phase. ये सारे एक ही phase में, it means plus plus plus, these are the in the same phase, and here are the another the same phase. So when the same phase are overlapped, so that means there is the bonding molecular orbital. So in this structure, we see that there are three bonding orbital. Yeah, bonding, we can say three bonding interaction. Okay, so the all bonding interactions, electrons are delocalized over four nuclei. And now come to the pi 2. So here we can see there is a one node is present. Okay, so the one node is present, it means there is the antibonding orbital. So that we can say this is the plus phase and there is the minus. So this is there the antibonding molecular orbital is formed. And we can see again there are the bonding orbital, and here are the again the bonding orbital. It means when the one node is present, so there are uh, one antibonding interaction and two are the bonding interaction. Okay, so two bonding interactions here and one antibonding interaction, bonding molecular orbital, and a higher energy than the pi 1 molecular orbital and not as strong. Okay, क्योंकि कोई भी सिस्टम है वो स्टेबिलिटी चाहता है. ठीक है, देन कम टू द थर्ड that is the y3 star. Star किसलिए कहा, क्योंकि first two are the they form the bonding molecular orbital, and here uh, pi 3 and pi 4 they form the anti-bonding molecular orbital. So here we can see there are the two nodes are present. Here the one node is here and the one node is here, so that we see the opposite phase is here present, plus and minus, then plus, then minus minus, and then minus plus. So we can see here there is only one bonding interaction is present and two anti-bonding interactions is present. Clear? So the antibonding molecular orbital, there are the empty at the ground state, है ना? And so there are the two nodes are the present. So this is there the two nodes are present, and in the last that is the y4 y star 4. Here we can see that there are the three nodes are present. यहाँ पे कितनी है, तीन नोड प्रेजेंट है. तो इसका मतलब क्या है कि there are the three anti-bonding interactions are present, but there is no any bonding interaction. Okay, so the strongly anti-bonding very high and the vacant at the ground state. So this is the pi molecular orbital of the 1,3 butadiene. So here the bonding molecular orbital of 1,3 butadiene are filled and antibonding molecular orbital are empty. Clear? So the butadiene has lower energy. This lower energy is the resonance stabilization of the कंजुगेटेड डाइन. तो पाई मॉलिक्यूलर ऑर्बिटल की वजह से क्या होता है, डीलोकलाइजेशन होता है, जिसकी वजह से हम उसकी स्टेबिलिटी जो होती है वो चेक करते हैं या बढ़ा देख सकते हैं. तो दिस इज द पाई मॉलिक्यूलर ऑर्बिटल इन द 1,3 butadiene. Okay, now come to the next, that is the again. So here now come to the again, that is the another molecular orbital, another pi molecular orbital which are present in the benzene. So in this topic, we are going to discuss about the orbital structure of the benzene and the delocalization of the electrons. Okay, so first of all, we know that the benzene has the ring structure. Okay, so there are the structure, the formula of the benzene is the C6H6. So here, according to the orbital theory, each of the six carbon atom in benzene is in the state of sp2 hybridization. We know about the hybridization. Here is the one s orbital and the two p orbital are overlapping, so that the formation of the sp2 hybridization. So now the three hybrid orbitals of each carbon form three sigma bonds. Okay, so कहाँ से आएंगे? So these two with the adjacent carbon atoms and one with the hydrogen atom. Okay, so there are the six carbon and the six hydrogen atoms lie in the same plane, and the angle between any two sigma bond is in the benzene, the sigma bond between the two sigma bond is the 120-degree angle. So therefore the benzene is a planar molecule. here is the structure of the benzene in which we can represent the pi molecular orbital. Okay, there is a possibility of overlap of unhybridized orbital in the both direction. We can represent it just like this. Here the this is the double bond. Okay, and again that is the again structure of the benzene. So here, in other words, the pi electron, we can say that the pi electron do not form a bond between only two carbon atom, है ना, जैसे किसमें हो रहा था, इन द केस ऑफ द इथिलीन में हम लोग देखते हैं, है ना, बट आर involved in the bond formation between more than two atoms. So this spreading over the pi electron known as the, we all know that word, that is the delocalization. Clear? So the formation of a molecular orbital as delocalization, so the formation of a molecular orbital involving all the 6 carbon atoms, and we can say that there are two continuous ring like electron cloud. Clear? कि जो हम इसको दिखाते हैं ना क्लाउड की फॉर्म में, तो दिस इज द इलेक्ट्रॉन क्लाउड, एंड वन अबोव एंड अदर बिलो द प्लेन ऑफ द सेम. यहाँ हमने दोनों को एक साथ दिखा रखा है. ठीक है, ये हमारा इलेक्ट्रॉन क्लाउड हो गया. हेयर इज द 1.39 angstrom between the carbon and length of the sigma bond, and here the carbon hydrogen is 1.09 angstrom. Okay, this is the structure of the benzene. And now this process is delocalized. It is a process of delocalization of pi electrons. The result in the bond with are stronger than the normal pi bond because of the delocalization. हम लगाते हैं ना उसको, कहीं भी लगाते हैं, बीच में सर्कल लगा देते हैं, इट मींस वो delocalization वाली स्टेज होती है. And the account for the stability of the molecule. So it may be noted that it is delocalization of the pi electrons which make the benzene is more stable than the hypothetical cyclohexatriene molecule. Okay, so this is the structure of the benzene, and here we can form the hexatriene in the pi molecular orbital in the hexatriene molecule also. And there is the formation of the just like the 1,3 butadiene. In the 1,3 butadiene there are the 4 carbons are present, and the 4 at the 4 atomic orbital, so that the 4 at the molecular orbital was there. And in the hexatriene, so it means the 6 carbon atoms are present, so it means 6 atomic orbital, and so there are the 6 molecular orbital are present. So that you should draw the structure of the pi molecular orbital of the hexatriene also. Okay. But now that we are discussing about the pi molecular orbital of the benzene. So here we can arrange the structure of the pi molecular orbital in benzene. There is the wave according to the wave function. So that here we can say that this is the and there are the 6 molecular orbital. Okay, तो वो जब 6 एटॉमिक ऑर्बिटल होंगे तो 6 मॉलिक्यूलर ऑर्बिटल प्रेजेंट होंगे, और वी सी दैट इनमें से 3 आर the bonding molecule, 3 are the bonding molecular orbital, and 3 are the anti-bonding molecular orbital. So here we can see that um, they are the first, second, third. These are the bonding molecular orbital, and here we can see the 4, 5, and 6 are the anti-bonding molecular orbital. So now here we can see that there are the pi orbital and the loops are present here, or in the first diagram we can see that all the loops are present in the same phase. It means जितना भी fill करे हुए हैं चाहे fill कर ले, या it means we can represent by the plus or minus. So fill is represented the plus means there the addition overlapping, ठीक है, or there the formation of the bonding molecular orbital. So in the first structure, for the pi one, there are the all the molecular orbital are present in the same phase. So these are the addition overlapping, or we can say there are the bonding molecular orbital. And here we can see that the 2 and the 3. Okay, 2 and 3 have the same energy. Okay, We can see here that there are the one node is present, that the red line shows the one node. तो वन नोड इस तरीके से भी लिख सकते हैं और हम इस तरीके से भी शो कर सकते हैं. तो जहां इट मीन्स नोड इज प्रेजेंट हियर, तो इट मीन्स देयर आर द opposite lobes here. So they can we see that plus and minus, or fill है or unfilled है. Here again plus and minus, filled or unfilled. So there is the formation of one node. Okay, and here again there is the formation of one node. We can represent uh, 2 and 3 which are found in the same phase. Now, and these three are found the bonding as the bonding molecular orbital. And now come to the 4, 5 and the 6. So these three are found in the antibonding molecular orbital, from the antibonding molecular orbital. And here we can see that जैसे जैसे नोड बढ़ती जाएंगी, it means जो energy है वो बढ़ती चली जाएगी. So in the 4 structure we can see there are the 2 nodes are present. देखा, we can see there are the 2 nodes are present. But ध्यान ये रखना है कि बिल्कुल इसके कॉर्नर पे नहीं आना चाहिए. तो एक नोड ये, and red line, another red line shows the second node. So there are the 2 nodes are present. Or we can check the every at each node there are the opposite lobes are present here. Okay, and in the psi star 5, star is representing the antibonding, and the psi star 5, psi star 5 is represented here at there are the 2 nodes just like this side. So here the two or the two nodes are present, and the phases are the opposite. Okay, then come to the sixth structure. So here we can say there are the 3 nodes are present. As we see that the 3 lines, they are here the cut, and these are the 3 nodes are present here. And at each node there are the different phases are present. Okay, and this is the 6th antibonding. So now we can see here that the first structure, as we see above in the first structure, the energy molecule, lowest energy molecular orbital for benzene have the zero node. Clear? The zero node है, इसका मतलब सबसे कम वहाँ पे molecular orbital होगा, कम energy वाला molecular orbital. That is the lowest energy molecular orbital for the benzene have the zero node between the individual p orbitals. So in this orbital, uh, electrons are delocalized over the length of the molecule, resulting in the greatest lowering the energy. Okay, and the here we can see that in this there are the 3 nodes are present. So सबसे ज़्यादा energy यहाँ पे होगी, that is the highest energy molecular orbital for benzene, and all phases are the alternate here. You can see now benzene with one node phase. So the 2 phases are present where which have the one node here. Okay. So, एक node इधर, एक node इधर. So this the 2 phases. It means the pi 2 and the pi 3. These are the 2 phases which have the only one nodal plane. So in benzene, these 2 molecular orbitals, pi 2 and pi 3, have the same number of the nodal planes, and therefore have the same energy. So thus result in our lowering the energy here. And these are the pi 4 and the pi 5. There are the 2 nodes, 2 nodal planes are here. So there are the 2 nodal planes are present. So these 2 orbital have the same energy. Okay, so the 2 sets are present which have the same energy. So the orbitals have the same energy. These are the pi 2 and pi 3 have the same energy, and another set is the pi 4 and the pi star 4 and the pi star 5. They both have the same energy here. Now, so this is the 2 node here, and the one structure, that is the pi 6, which has the 3 nodes are present here. And we know that at the node there is the probability of finding the electron is 0. Okay. So as we know that the number of nodes are increased, so that the energy will be increasing and the stability will be less here. So at every system find to the stability. Okay, so this is the pi molecular orbital of the benzene and the 1,3-butadiene. So a short revision of this topic. That is the firstly we know that the structure of the benzene, and we know that how the pi molecular orbital is formed. So we know that when the atomic orbital overlap, then there is the formation of the molecular orbital, but only those orbital which is perpendicular of the molecular axis. ठीक है, वही बना सकते हैं. So pi molecular orbital formed होते हैं कैसे कि for the addition overlapping, and for the addition overlapping, so means there is the formation of the bonding molecular orbital, or we can say that there are the same phase is present. And when we can say that if the subtraction overlapping is present, so it means there are the formation of the antibonding molecular orbital. It means the different phases are present. Okay, so this is the structure of the 1,3-butadiene, and here we find that the four atomic orbitals, so that the four molecular orbital are present. These are the first is the pi 1, second is the pi 2. We can count the node and the antinode node interaction here, and in the first is when that is a ground state, or here there is a no node present, any node is not here. So all the bonding interaction are present here, and in the when the one node is present, so it means there is the one anti-bonding interaction, and there is a two node are present, so there is a two anti-bonding interaction. Okay, and the last is there the three nodes are present, so that there are the three anti-bonding interaction. Okay, then come to the pi molecular orbital in the benzene. So this is explained by the delocalization of the benzene. And in the structure of the benzene, we know that it shows the ring structure, and here is the um, it shows the sp2 hybridization, and the three hybrid orbital of each carbon from the 3 sigma bond. So two with the adjacent carbon atom, and the one with the hydrogen. So six carbon and six hydrogen atoms like. So in the bond angle, the angle between any two sigma bond is 120. So this is a structure in which the possibility of the overlap of unhybridized orbital in the both direction. Okay, then this is the bond length, and now that is the pi molecular orbital structure benzene we can represent here, and here we can compare the benzene with the hexatriene, है ना. उसके साथ भी कंपेयर कर सकते हैं, बट उसमें क्या ओपन चेन होगा, यहाँ पे हमारी बेंजीन में रिंग चेन होगा. ठीक है, इट इज जस्ट लाइक द ब्यूटाडाइन. In the 1,3-butadiene, there are the four atomic orbitals, so that the four molecular orbital are present. Okay, so and the in hexatriene, there are if the six atomic orbital, so it means there are the six molecular orbital are present. So that we can compare then the hexatriene and the benzene stability, and we know that the stability of the benzene is more than the hexatriene by the reason that is the delocalization method. Delocalization is present in the benzene. Okay, so here is the we know now the bonding and the anti-bonding interactions, and one more thing is here that uh, that is the we know the aromatic character. So some important properties of the aromatic compounds. So these are the just like the first is it should be that they are usually cyclic compound, and their molecules have the same shown in a plane or the X-ray and electron diffraction method. So these compounds are the resistant to usual addition reaction or the substrate compound. ठीक है, sorry, addition reaction or the unsaturated compounds, and they show usually the stability as shown by the low heat of the hydrogenation and the heat of the combustion. So their molecules have the resonance stabilization. The pi electron in the ring are the delocalized. So this is the some points which are related to the aromaticity. So by all these properties or all these explanation, we can explain the pi molecular orbital in the benzene and the 1,3-butadiene. So you have to prepare the question pi molecular orbital in benzene and the 1,3-butadiene. For any doubt of those, you can contact with me. Thank you.